the LeetCode coding challenge, and today we are going to solve our next problem statement, longest subarray of ones after deleting one element. Let's start. Given a binary array nums, you should delete one element from it. Return the size of the longest non-empty subarray containing only one in the resulting array. Return 0 if there is no such subarray. So we have given an array. We need to delete one element from it. And after deleting that element, we need to find the longest subarray containing only one, and return 0 if there is no such subarray or 1. But if we delete a 1, the maximum size of subarray will come as 2, because we need to find a subarray that consists only 1. But if we delete a 0, we can find a subarray that of the size 3. So one point to pick, we need to delete 0 out of it, because deleting 1 if the 0 is there, it do not make sense. For the second test case, if we delete the first 0, it so the maximum size of subarray will come as 3. If we delete the middle element, the size of subarray will come as 5. If we delete this 0, the maximum size will come as 3. So we deleted the middle element and the maximum size came as 5. For this element, any one we delete, it do not matter. The maximum subarray size will come as 2. Let's come to the solution part. We can solve this problem statement using the sliding window approach, and let's come to that. So this is our test case, and this is the back and front is our sliding window. So front is the front of the window and back is the back of our sliding window. We are counting number of 0 in our window. The maximum number of 0, that is the maximum number of element allowed to delete. So in this case, the maximum number of element is 1, and our maximum window size. So this will be our answer. So at first we initialize our pointer. Right now these all are 0. On next iteration, we moved our sliding window. Now the front goes to 1, and number of 0 count in this window is 1. And our maximum window size goes to 1, the size of the window. So maximum window size, you can find it by doing front minus back. So 1 minus 0 is equal to 0. Now we move forward our front pointer again. So for every iteration, we are moving our front pointer so that our window go from left to right of the array. So for this window, the 0 count, number of 0 is 0. Now again we moved our front pointer, the number of 0 is 0. We are updating our maximum window size. Now it comes as 2. Now it comes as 3. Now one thing, if our 0 count goes greater than 1, we need to move the window from back side also. So for this case, for this window, the number of 0 is 1, but if we move our front pointer, now the number of 0 is 2, which is greater than k. So we need to move the window from back side also. So that's why we moved our window from back side. And now the 0 count is 1 again. Then we moved our front pointer. And we are calculating max window size also, doing front minus back. So 3 for this. And then we again have moved out our window. And our maximum window size is 4. Then again we moved it forward. Again our maximum window size is 0. Now if we take this window example, now we have the 2 0. So now we need to move again the window from back also. So we moved from back, and again it is 2. So we moved from back again. So now our array is completed. So the few point to notice, we are moving our front pointer every time. We are moving our back pointer only when our count of 0 go greater than k. And we are calculating our maximum window size every time. So at last, the answer for this will be 5. So let's jump to the coding part and implement this solution. So we have our pointer back equal to 0, front equal to 0. The maximum number of element allowed to delete is 1. Our max window size is front minus back. and our zero count initially is 0. Iterate your window from left to right. So front is less than names.length. And remember, we are incrementing our front every time. So let's do front plus plus. If our front pointer is pointing to 0, we need to increment our 0 count. If our 0 count goes more than our limit value of k, then we are saying move back pointer also. But we need to keep track how many zeros is there in the window. So if the back pointer is equal to 0, we decrement our 0 count. Now we need to find our max window size also every time. Max window size, whatever is current window size, comma max window size. Return our answer. Let's run the test case. Our test case is working. Let's submit the solution. And yeah, our solution is also working. Thanks for joining the session. Let's meet tomorrow.